Okay, so welcome back for part two. We just have two examples to do in this section, and then we'll be done with section 9.1. Okay, we'll start with the top one. A study of 200 randomly selected people driving vehicles in Washington and 250 randomly selected people driving vehicles in Vermont shows that 93% of people driving vehicles in Washington and 88.8% of people driving vehicles in Vermont wear seatbelts while driving. Oh, another seatbelt problem. Okay. At a significance level of 0.10, alpha equals 0.10, can you reject the claim that the proportion of people who wear seatbelts while driving is the same? Okay, so there's our claim. Our claim is that the proportion of people who, oh, I like this. This is very, very similar to the first one. Right? All right, so I'm going to start where I always start with these two proportion problems. Who's one, who's two? Washington shows up first, so I'm going to call them 1. Vermont shows up second, they're 2. Right? Our claim is that it's the same. So our claim would be that the proportion for Washington is the same as the proportion for Vermont, or that P1 equals P2. To turn that into a pair of hypotheses, we're going to have a null and an alternate. Our null is going to be, of course, that P1 equals P2. It's the claim, right? Our alternate will be that P1 is not equal to P2. Our data, okay, I've done a couple of these. I know what I need. I need an X1. I need an N1. I need an X2. I need an N2. And I need an alpha level. Again, I'm lazy. I picked the easiest thing first. There's my alpha level. All right? Let's look at population 1 data. 200. That's Washington, that's 1, so 200 is sample size 1. 250, that's Vermont, that's 2, so sample size 2, and 2, 250. Uh-oh, this is the same thing as the last time. They did not give us what we need. They gave us a P1 hat at 93%. And they gave us a P2 hat at 88.8%. So I got to turn P hats into X's. Good thing is I know how to do that. I can make that work pretty easily. Sorry about that. I had to adjust the size real quick. I can find X1 by taking sample 1, 200, and multiplying it by my proportion 1. So I get that X1, 186. I'll do the same deal for the second one. That's going to be 250 sample size times 0.888, and I get 222. So that's everything I need there. I'm ready to run the test. So stat, test, oops, stat, let me try that again. Test, 2 proportion z test, x1 186, n1 200, x2 222, n2 250. Alternate is there not equal to. I'm going to calculate my standard test statistic that is 1.5, but I'm not too worried about that. I want a p-value. I get a p-value of 0.13, right? When I compare my p-value to my alpha, p is greater than alpha, so we fail to reject that null hypothesis. And if I'm failing to reject the null hypothesis, and my claim was the null hypothesis, then I would say there is not enough, or there is not sufficient evidence to reject the claim. So there is not enough evidence to reject the claim that they are the same. Or kind of more in regular words, Claim is that the proportion who wear seatbelts is the same in Washington and Vermont. We gathered some data. The data that we gathered is close enough together. They're not the same, obviously, but close enough together that I can't say they're different. So I don't have enough evidence to say that the proportions aren't the same. And that's what's going on here. Okay. Our last example for section 9.1 before we move on to 9.2. Okay. A medical research team conducted a study to test the effects of a medication to treat patients with post-traumatic stress disorder, PTSD. At the end of the study, the researchers found that of the 42 randomly selected subjects who took the medication, 28 no longer met the criteria, the diagnostic criteria, for PTSD. Of the 37 randomly selected subjects who took the placebo, 12 no longer met the diagnostic criteria for PTSD. At a significance level of 0.01, can you support the claim that the reduction rate in the diagnostic criteria for PTSD is higher for those who took the medication than for those who took the placebo? Okay. 2 samples. I'm comparing them. I got to call a 1 and a 2 here, right? Again, I'm just going to do it in the order. Right? So meds, that's group 1. Placebo, that's our group 2. Okay? Our claim is that the reduction rate is higher for those who took the meds than those who took the placebo. That is that the rate of which you are no longer diagnosed as PTSD is greater than 2. Okay? All right. Let's make some hypotheses out of that. Since our claim does not include equality, it's the alternate. Whoops. So our claim is the alternate here. And our null would be that they're equal or less. But we write just equal because that's how the authors of the book set it up. Okay? I've done so many of these now, I know what I need. I need an x1 and an n1. I need an x2 and an n2. And I need an alpha. I'm lazy, so I do the easy one first, my alpha level. Let's see. Let's go back and look. Okay. So 42 took the meds. 28 of those no longer met the criteria, so 28 successes. 37 took the meds, or didn't take the meds, took the placebo. 12 no longer met the criteria. Now, this is the first time where I'm worried about something. In the other examples we did, our samples were huge, so I wasn't too worried about that 5 successes, 5 failures business. But here my samples are kind of small, so I'm a little worried about it, so I'm going to explicitly check something. So I know that I do not have p-hats anywhere, but I also know this. N1P1 is X1, and N1Q1 is N minus N1 minus X1. And if I swap out for 2's, it's all the same math. So that means that X1 is my number of successes, and N minus X1 is my number of failures. These are hats, by the way. I'm sorry about that. So saying everything needs to be 5 means I need to look at X and make sure X is bigger than 5. And I need to make sure that the complement of X with respect to the sample size is also bigger than 5. So in group 1, X1 is 28, way bigger than 5. The sample size is 42, so that means we're looking at 14 in its complement, also bigger than 5. When I look at sample 2, X2 is 12, so that's bigger than 5. 37 minus 12, what's that, 25? Also bigger than 5. Okay. Now, I didn't worry about that in some of the previous problems simply because the samples, the data was so big, I didn't need to worry about it. Here, I was slightly worried, so I checked it. I feel good about it. Now I can run the test. Stat, tests, 2 proportion z-test, x1 28, n1 42, x2 12, n2 37, greater than, for my alternate, calculate away. If I needed this test statistic, it's there, 3.04. I need the p-value though. And I get a p-value of 0.001. When I compare p to alpha, 0.001 is less than alpha, which means we are going to reject the null. Since the claim was the alternate, I'm rejecting the null. When the claim is the alternate and I'm rejecting the null, I say there is enough or sufficient evidence to support the claim that, and now let's see, how do I say this? The reduction rate is higher with the medication. So wherever this information is from, if you have PTSD, looks like the data shows you should take the meds. The meds will help you out. Okay. All right, that brings us to the end of section 9.1. I'll see you for the next video, which is going to be section 9.2.